In the frozen dark of space, something extraordinary is born from destruction. When a massive star 20 times heavier than our Sun runs out of fuel, gravity wins. In less than a single second, the star's core collapses into a sphere smaller than Manhattan. Imagine cramming all the mass of our Sun into a ball just 12 miles across. The result? A neutron star so dense that a teaspoon of its matter would outweigh mountains. This crushing transformation marks the beginning of one of the universe's most terrifying objects, a magnetar. Its magnetic field is 1 quadrillion times stronger than Earth's, capable of tearing atoms apart from thousands of miles away. A star's death gives rise to a cosmic monster, tiny, dense, and impossibly powerful. And this is just the surface of their mystery. If you're fascinated by the extremes of our universe, don't forget to subscribe, because what comes next will make these monsters even stranger. The numbers behind a magnetar's density and gravity are beyond imagination. A single teaspoon of magnetar matter would weigh billions of tons more than an entire mountain compressed into something smaller than a sugar cube. On its surface, gravity is 200 billion times stronger than Earth's. If you weigh 150 pounds here, you would weigh 30 trillion pounds there, crushed flatter than a hair in less than a microsecond. Even light itself struggles to escape, redshifted and dimmed as it climbs out of the magnetar's gravitational well. Time bends too. An hour near its surface could mean nearly an hour and a half passing in the rest of the universe. Every law of physics we know groans under the strain of these conditions. To walk on a magnetar would mean facing forces greater than the thrust of a Saturn V rocket with every step, while the escape velocity reaches a third of the speed of light. Density and gravity here don't just defy human limits, they rewrite reality itself. If density and gravity make magnetars terrifying, their magnetic fields turn them into pure nightmares. Earth's magnetic field guides compasses and paints auroras in the sky. Hospital MRI machines generate fields 10,000 times stronger. But a magnetar's field? It reaches 1 quadrillion times Earth's. Under these conditions, even the structure of atoms warps. Hydrogen, normally round and simple, is stretched into long, needle-like shapes aligned perfectly with magnetic field lines. Chemistry itself ceases to work as we know it. The vacuum of space near a magnetar isn't empty anymore, it becomes distorted, alive with quantum particles flickering into existence. At just a few hundred meters away, these fields would tear apart the very atoms in your body, breaking DNA, unraveling molecules, and dissolving matter at its most fundamental level. A magnetar's magnetic fury is so overwhelming it could erase every credit card on Earth from the distance of the moon. This is magnetism on a cosmic scale, raw, violent, and unstoppable. Magnetars are not quiet monsters, they erupt with a violence that eclipses entire galaxies. Their magnetic field lines twist like rubber bands stretched to the breaking point. When those invisible bands snap, the energy released is catastrophic. In less than a heartbeat, a magnetar flare can unleash more energy than our Sun will produce in 100,000 years. These outbursts are so bright they can temporarily blind satellites and ripple through Earth's atmosphere even from tens of thousands of light years away. At the heart of the eruption, temperatures soar to billions of degrees, accelerating particles to near light speed and blasting space with gamma rays, the deadliest form of radiation. Astronomers call them hyperflares, cosmic explosions that rival supernovae but happen on a star no larger than a city. To witness one is to see the laws of physics pushed past their limits. Magnetars don't just shine, they detonate, rewriting the universe in bursts of unstoppable light. The discovery of magnetars was pure accident. On the 5th of March 1979, satellites built to monitor nuclear weapons suddenly detected a blinding flash of gamma rays flooding Earth's atmosphere. For a moment, it looked like an attack. Military alarms blared and scientists scrambled for answers. But the signal wasn't from Earth at all. It came from the Large Magellanic Cloud, 160,000 light years away. In just a tenth of a second, the source released more energy than our Sun produces in 1,000 years. The burst was so powerful, it bounced off the moon and echoed in Earth's upper atmosphere. When astronomers turned their telescopes toward the source, they saw nothing, an invisible monster hiding in the dark. Only later, with the arrival of X-ray observatories in the 1990 seconds, did the truth emerge. These weren't ordinary neutron stars, but an entirely new class magnetars, magnetic titans capable of flares that outshine entire galaxies. Deep within a magnetar's crust, unimaginable stresses build. The outer shell is made of ultra-dense matter, a crystalline lattice, harder than diamond yet constantly crushed by magnetic fields stronger than anything else in the universe. Over time, those fields twist and strain the crust until it finally snaps. The result is a starquake, an explosion of seismic energy so violent it makes every earthquake in human history look trivial. When the crust fractures, magnetic field lines whip and reconnect, releasing bursts of X-rays and gamma rays that travel across the galaxy. The surface shakes, heating to tens of millions of degrees in an instant. Even the magnetar's spin can glitch, changing by measurable amounts, as if a cosmic clock suddenly skipped ahead. These quakes are so powerful, they send ripples through space-time itself, faint gravitational waves that whisper across the universe. A magnetar doesn't just flare, it quakes with a violence that reshapes matter at the nuclear level. When magnetars are young, they spin with breathtaking speed, completing a rotation in just a few seconds. This rapid spin transforms them into cosmic engines, whipping their magnetic fields through space like the beam of a deranged lighthouse. Charged particles are flung outward at nearly the speed of light, creating storms of plasma that glow in X-rays. The rotation itself drags space-time around the star, twisting magnetic field lines into knots that eventually snap with catastrophic force. But as the years pass, magnetars slow. The energy they once shed steadily in constant winds begins to erupt in violent bursts instead. Older magnetars unleash fewer flares, but the ones they do produce are devastating sudden explosions capable of outshining entire galaxies. Some enter dormant phases, invisible for decades, only to roar back to life without warning. This evolution from frantic spin to unstable quiescence makes magnetars unpredictable cosmic time bombs whose behavior no telescope can fully anticipate. Across the universe, mysterious signals flash for mere milliseconds, bursts of radio energy brighter than anything else in the sky. For years, astronomers puzzled over these fast radio bursts, or FRBs, which seem to appear from nowhere. Then, in April 2020, the mystery cracked open. A magnetar within our own Milky Way, SGR 1935 plus 2154, erupted. Alongside its usual X-rays, it emitted a blistering radio burst powerful enough to be detected across the galaxy. For the first time, scientists caught a magnetar in the act, proving that these monsters can generate FRBs. The mechanism is as violent as it is elegant. When magnetic field lines snap and reconnect, they hurl billions of electrons along invisible highways at near-light speeds. These electrons move in perfect unison, releasing intense radio waves in a flash. Magnetars, it turns out, are not just destroyers, they are cosmic beacons, sending millisecond signals that travel billions of light years to reach us. Magnetars are rare, but their potential danger to life is staggering. The nearest known sits safely about 9,000 light-years away, but what if one drifted closer? Within 1,000 light-years, its bursts of X-rays and gamma rays could shred Earth's ozone, leaving us exposed to lethal solar radiation. At 500 light-years, the sky would darken under a chemical haze, while plants and food chains collapsed. Closer still, 100 light-years, and Earth's upper atmosphere could be stripped away entirely, bleeding into space. At 50 light-years, a single flare would mimic nuclear war across the globe, igniting climate chaos. And at 10 light-years, our magnetic shield would collapse, exposing the surface to relentless cosmic rays. A magnetar within just 1 light-year would mean instant extinction, unraveling matter itself at the atomic level. Thankfully, their formation zones are far from us. But the sheer distances at which they threaten reveal just how monstrously powerful they truly are.